All right, today you are going to do rational numbers. So the first thing obviously we have to do is define a rational number. So a rational number is fancy for the word fraction. And over here we have a symbol of a fraction, something over something. And as a matter of fact, you have been using the symbol sign for a fraction ever since you learned division. Something over something. That's where the division sign came from. It represents a fraction. So in high school, we say a rational number is any number that can be expressed as a fraction. And you may think, oh wow, isn't that every number? But it's not. You know irrational numbers. You cannot write pi as a fraction. And why is that? Because of the more sophisticated definition we have for a rational number. A rational number is any number that can be expressed as putting one number over another number. A and B have to be integers. That's why you're not allowed decimals. They have to be integers. And the B obviously can never be 0. You can't have a 0 on the bottom of something. That's undefined. So that's no-no. And you can't say, well, Mrs. Trulin, isn't pi over 1 a fraction? No, because it's defined as A and B are integers. And I don't see pi as an integer. Integers are what you learn to count on. 0, 1, 2, 3, 4, 5, 6. And then, of course, the negatives. -1, -2, -3, -4, -5. So those are all your integers. All right, so we're going to start off easy in this chapter. And we're going to have you turn decimals, dirty decimals, are going to get turned into friendly fractions. So the first example here, 0.7, is pretty easy to turn into a friendly fraction. We know a fraction has to be something over something, and you pretty quickly know that this is 7 over 10 because it's 7/10. But that brings us to the crux of today's lesson, and that's a repeating number. How do you turn a repeating decimal into a fraction? It's pretty easy to do, and some of you by the end may be able to pick up the shortcut, but I'm going to take you through it the long way. So let's get rid of all this, and let's delete him and bring this over. Okay, so how do we turn that into a fraction? Here we go. Step 1. We write a let statement. N equals 0.7 with a bar over it. Step 2. Multiply by a power of 10. And your powers of 10 are like 10, 100, 1,000, 10,000. Those are all powers of 10. Not a multiple of 10, not 10, 20, 30, 40, 50, 60, but a power of 10. And you can pretty much do any power of 10 you want, but I tend to pick the lowest one that works. In this case, I see one number repeating, a 7. So I'm going to multiply by the first power of 10. Now, if you're wondering how I got this 7.7 repeating, think of it this way. This is the number 7777777 repeating. How do you multiply by a 10? You just move the decimal one place to the right. Step 3. Bring down step 1. And subtract from step 2. All right, so I'm going to bring this step down. I'm going to write it underneath. And if you remember, you have to line up your decimals. So when I subtract now, 10 n's take away 1 n is 9 n's. Over here, something happens. 7.7 repeating, subtract 0.7 repeating is 7. Because if I were to write this out, subtract, aren't there always 7s lining up? 0, 0, 0, 0, 0, 0 when I subtract? And now can you see the fraction forming? Divide by 9, divide by 9. So here's my fraction. 7 over 9. That's how I turn 0.7 into a fraction. All right, so I'm going to take these steps right here. I'm going to try and group them together. We're going to carry them along to our next page. Nope, that didn't work. There they are. All right. How are we going to take 0.45? Well, step 1 didn't make it over. So step 1 is always that let statement. We just let n equal 0.45 repeating. Step 2, multiply by a power of 10. Well, I'm going to multiply by 100. And if you're sitting there going, wait, how come you're multiplying by 100 now, and the last one you multiplied by 10? Well, it's really simple. How many numbers do you see repeating here? 1, 2. So I multiply by 10 to the second power. That's how I got 100. On the previous page, how many numbers did you see repeating? Just 1. So I multiplied by 10 to the first. And if I had 3 numbers repeating, I'd multiply by 10 to the third. Okay, step 3. Bring down step 1. Okay, so that means I'm going to bring this down. N equals, I'm going to line up my decimals. And I'm going to subtract the 2. 100n take away n is 99n. And this is what happens when you multiply by that power. This is forever 45 repeating, 45 repeating, 45 repeating, 45 repeating. And this is 45 repeating, 45 repeating, 45 repeating, 45 repeating. So they're just all going to cancel out. I'm left with 45. Write as a fraction. Of course, we always have to reduce. So let's see there. 9 goes in there 5 times. 9 goes there 11. So that is your fraction. 5 over 11. And if you don't believe me, take out your calculator, do 5 divided by 11, and you're going to get 0.45 repeating. Okay, I think now you're kind of onto it. There are my steps. Always have to add in that step 1. Write as n equals 117. Multiply by a power of 10. Hey, guess which power I'm going to multiply by? That's right. I heard Katie Kana yell it out all the way from her house. She said she's going to multiply by 1,000. Because there are 1, 2, 3 numbers repeating, so that means she multiplies by the power of 10 that's raised to the 3rd power. And now I'm going to move this decimal over 3 places. Step 3, bring down step 1 and subtract. Careful to line up your decimals. Goes 999n. So 117 over 999. And if you're wondering, does that reduce? I hope you all know your little trick. The number 117, if I take 1 plus 1 plus 7, if I add up all the digits, I get 9. Since 9 goes into the sum, 9 must go into 117. So 9 goes into 117 13 times, and 9 goes into 999 111 times. And if you check yourself, 13 divided by 111 does indeed give you 0.117 repeating. And the last one we're going to look at is this. Notice it's a repeating decimal. It's actually the decimal 3.07555555. So let's go through our steps again. There they are. By now, hopefully, you remember. Step 1. That's right, that's good, Mike Nab. N equals 3.075 repeating. You just rewrite it as a let statement. Step 2, I got to multiply by a power of 10. Well, how many numbers are repeating up here? Just 1. So I'm going to multiply by 10 to the 1st power, which is 10. All right, I'll multiply n by 10, and I'll multiply this side by 10, so that means I move the decimal place over once. Step 3, bring down step 1 and subtract. I'm going to bring it down, n equals, I'm going to line up my decimals, 3.075 repeating. Now, careful here. Let me rewrite that so you can see it. 5 here. What number is here? No, not a 0. A 5. Because it's repeating. So that means I have an endless amount of 5s going this way. And likewise, I have an endless amount of 5s going this way. So when I subtract, all these repeating 5s cancel out. Let's just get rid of them because I don't want to look at them. All right, so now let's just subtract. 15 minus 7 is 8, 6. 30 minus 7 is, 30 minus 3 is 27. 10 minus n is 9n. Divide by 9. And Is that my answer? Nope. If we come back to our decimal definition, it's any number that can be expressed where a and b are integers. And if I come back to my last slide here, 27.68 is not an integer, it's a decimal. It's a dirty decimal hanging out in our friendly fraction. So we can fix that. We'll just move this decimal place over 2. But if we move the top decimal over 2, we move the bottom over 2. So that's our new fraction. And of course, we're going to reduce it. So let's see, 2768. I believe reduces down to, you can do that on your calculator, 692 over 225. And that is our fraction. Okay, thanks. Bye.